All right, so this is section 10.4, congruent chords and arcs. We want to be able to recognize when chords are congruent and use them to solve problems. This turns out to be a pretty easy lesson, but we do have a little bit of vocabulary to learn. So first of all, we want to make sure we understand what a chord is. So that word chord there, and a chord is a segment in a circle. So here we have chord AB and chord CD. Both of these would be considered chords. Not to be confused with, say, segment EH. What would segment EH be called? Yeah. Okay. A radius, yeah, that's right. All right. Yeah, EH is a radius. Okay, so here we have a couple of chords, and we want to be sure that we understand when chords are congruent. This turns out to be pretty obvious. Two chords are congruent if and only if. We have two cases here where those yellow chords would be congruent. And they would be congruent when, I get another highlighter here. I love highlighters. I've added it to my list of things I want to have in my classroom for next year. Is just more highlighters. I think they're so multi-purpose, you know? Okay. Sorry. I digress. All right. So if two chords are congruent, if and only if, their corresponding arcs are congruent. So here is AB's corresponding arc, and here is arc CD, its corresponding arc. So two chords are congruent if and only if their corresponding arcs are congruent. All right, corresponding arcs are congruent. So what does that mean? If arc AB, so if arc AB is congruent to arc CD, then we also know if the arcs are congruent, then their chords are congruent as well. Then AB is congruent to CD. And this is a bidirectional arrow. It goes forwards and backwards. So if you know that the yellow chords are the same length, then we get to know that the orange arcs are also the same. Okay, make sense? All right, sure. All right, the other thing that I want to talk about is being equidistant. I need another highlighter. I'll get another highlighter. You guys are like, what's going on? She's gotten bonkers. Okay, now I think color is so important. Okay, another way we know if two chords are congruent is if they are equidistant. I forgot, I-S-T-A-N-T, forgot how to spell for a minute there. Equidistant from the center of the circle. And what does it mean to be equidistant? Well, first of all, we have to understand, how do you measure something? I did this last year too. How do you measure how far you are away from a wall? You know what I mean? Arm's length. So tape measure, yeah? Okay, so I have a tape measure here, and I want to know how far away am I from the board. So how do I measure? Do I go like this, and I'm like, oh, look at that. I'm 59 inches from the board? No. Does that make sense? Am I 59 inches from the board right here? No, maybe 60. So how do we, okay, here, wait, oh, what about this? Is this better? Now I'm 51 inches from the board. That's not right either, is it? How do you know how far away from the board you should be? How do we measure that? Straight at it. Yeah, so you got to come straight into the board, as in perpendicular to that board. So right here, now I'm standing at 33.5 inches from the board, okay? My tape measure is perpendicular to that wall, okay? That's how we measure how far away you are from something. Being perpendicular is key. And so when I look at this picture that we have here, I know things are equidistant when we have that distance at a right angle. So this little green part here, those segments, FE and EG, if those are congruent and they are perpendicular, if FE is congruent to EG, so if those green perpendicular segments are congruent, then my chords are going to be congruent too. So AB is congruent to CD, all right? So again, these are how we can show two chords are congruent. So the arcs can be the same, then the yellow pieces are the same. The green pieces can be the same, then the yellow pieces are the same. And again, that's a bidirectional arrow, so it goes forwards and backwards. Okay, meaning if the yellow things are the same, then the green things are too. Okay, does that make sense to you? Color helps here. All right. Okay, here is another, I think probably the most useful tidbit about circles and chords. And if there's anything you remember, I hope it's this. And I'm going to draw a sort of separate circle picture here, and I hope that you will too. It doesn't have to be huge, but let's just draw a little circle to the side here. So let's say I draw a chord on my circle. If I draw a radius or a diameter, but I'm going to just draw a radius, and that radius is going to be perpendicular to that chord. Being perpendicular is very key here. So if I draw a radius perpendicular to a chord, and I can draw a radius kind of anywhere, can't I? Like I could draw a radius from here to the end of my chord. There's a radius. But I could also draw the radius so that it's perpendicular to that chord. Same radius, same length, okay? But when it's perpendicular, it actually bisects the chord. So it cuts this chord into two congruent pieces. And consequently, it also bisects the arc that it's cutting as well, okay? And that's really an important thing to know, that you can always get a perpendicular and it's going to bisect it. It's really kind of cool. And again, that really just comes from triangles. If you connect the other radius, you can get a hypotenuse leg sort of congruent triangles going on. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So very, very good information. And I kind of just like this picture instead of writing out all of the different little parts there. So good picture is worth 1,000 words. Okay, so let's look at a couple of problems here. Number 2, what's congruent? True. So what I'm getting at here is the arcs are congruent. So we have congruent arcs, and that would imply that we're going to have congruent chords. Okay? So this is the reasoning I'm looking for here. They have marked we have congruent arcs. So their corresponding chords would be congruent as well. So we can say that 52 is going to be equal to 18x minus 2. Do I need to solve that, or can you guys solve that? Good. All right. So now on number 4, what is marked congruent? The chords. So we have congruent chords. And what do we know if we have congruent chords? Congruent arcs. All right, so they're corresponding arcs, and I can tell that it's an arc measure because of the degree symbol. All right, so these are congruent arcs. So once again, what's my equation going to be for this? Sure. 5x plus 6 is equal to 11x minus 72. And we can go ahead and collect our x's on one side and solve. We don't need to solve it, right? We're good? Yeah? Okay, good. All right, perfect. Let's look at, let's look at 5, because that one requires a little more thought here. Number 5. All right, what do we know that's congruent? All right, so we have congruent chords marked, which means that we have congruent arcs. What do I do with that information? How does that help me? So I know my arcs are congruent, so that arc and that arc are the same. So what should I do with that? You could do that. You absolutely could. I was thinking that we have 2 of them. So 2 6x minus 20s plus the 76 should equal, this arc plus 76 should equal how many degrees? 360, which is exactly what you said, Bella, just in reverse. So, okay. Let's see. What do we have going on in number 6 here? So in number 6, they're giving me MP. MP is the length of a segment here. It's this little segment. I'm going to color it green. So MP is this green bit, and PN is this other little green segment there. What do we know about those? They are equidistant. Yeah. We can see here that on our picture we have congruent arcs. If we have congruent arcs, then I know that I have congruent chords. And since I know I have congruent chords, they must be equidistant from the center. So the next thing I can conclude is that they are equidistant, meaning the green things are equal. So it turns out that MP, so 5x minus 34 is going to equal 2x minus 4. All right, equidistant. I'm going to highlight equidistant because that's what that means, that those 2 perpendicular segments are congruent. All right, any questions so far? Pretty much just setting things equal, yeah? It's not too bad, right? Let's turn the page. Okay, let's see. I used yellow for chords. Okay, so on number 7, we have DE. DE is a chord. And we have FG, and FG is a chord. Tell me what we know for sure. Where do we start here? Yeah. In a picture, they're telling us that we have equidistant, we are equidistant from each chord. All right? So they're telling us the marked things here are equidistant. That's the green things. They are perpendicular, so that means they're equidistant, which means that we're going to have congruent chords. All right, so DE, 11x plus 15 is going to equal 32x minus 27. You can solve for x and plug it back in. All right, how are you feeling about this? Okay? Good? Good? Okay. Let's look at number 9. In circle Z, if RS is a chord, and a measure of arc TY. So arc TY is 42 degrees. That's just a portion of an arc there. Find each measure. Yeah, so why? Why do we know that? Yeah, we've got a little perpendicular radius coming in, so we have two equidistant pieces, which means if we're equidistant, then we also know that our arcs are congruent. And then, of course, I said arcs. I meant chords are congruent, which means all their arcs are also congruent. So if TY was 42 degrees, this, and it gets bisected. So that's really why. When we come in perpendicular to those chords, the arcs get bisected, the chords get bisected. All right, if RS is 18, what's RW? Things get bisected. So we have RW is 9 and WS would also be 9. Let's see, TV. What would TV be? Also 9, yep, because we're equidistant, we have congruent chords. I'm going to write that down. Equidistant means we have congruent chords and congruent arcs. So lots of things there. So TV is 9, TU is 18, WS is also 9, and YU, we said already, was 42 degrees. And what's our S? 84, yeah, 84 degrees. All right. Again, congruent chords and congruent arcs. I really like my little shorthand notation here with colors. I think is really helpful here. Ha, there we go. Congruent chords and congruent arcs. Good? All right. Okay, let's skip down to 13 and 14. So use the circle below for questions 13 and 14. Find VW. VW is the whole chord. And when you look at this picture, they've given us a tiny bit of information. What have they given us? A 5 and a 13, yeah. But we also have a right angle. So we have a right triangle. So we have a 5 and we have a 13. Can I figure out this piece? Doing what? Pythagorean theorem, yeah. So we have x squared plus 5 squared equals 13 squared. X squared plus, what is 5 squared? 25 equals, what's 13 squared? 169. And then we need to do what? Subtract 25, we get x squared equals 144. And then square root both sides, what do we get? X equals 12. This is a 5, 12, 13 triangle. This is a really common, it's called the Pythagorean triple. And so these are common measures that come up a lot. All throughout math, you're going to see these. And if you just memorize it, the 5, 12, 13 triangle, you're good to go. Another one is a 3, 4, 5 triangle. And one more is a 7, 24, 25. These are the 3 most common ones. But of course, we can all multiply them all as well. So like if I multiply everything by 2, a 6, 8, 10 is another Pythagorean triple. Okay. So this is a 5, 12, 13 triangle. And so if ZW is 12, what's ZV? There's a huge bug on there, isn't there? All right. And so what is VW? 24. All right. This is really interesting. Okay, it says find the measure of arc YW. Find the measure of arc YW. We want this arc right here. This is a really interesting question, so it's I like it here. In order to know the measure of this arc, I need to know the measure of this angle. And so I'm going to redraw this little triangle. So we have just another picture here. So this is the angle I'm interested in, that's angle X. And we know that we have the 5 and the 13. I need to know the measure of this angle. And if I can figure out the measure of that angle, then I also know the measure of its corresponding arc. So central angle and arc are the same. It's a right triangle. SOHCAHTOA, yeah, good. SOHCAHTOA. So this is a trig question, and I want to find this angle. And which sides have they given me information on? Yeah, adjacent and hypotenuse. So that's going to be a cosine I'm going to set up. Cosine of angle X equals adjacent over hypotenuse. So cosine of X equals 5 over 13. And how do I get the X outside? It's trapped inside a cosine function. How do we get rid of it? The inverse function, yeah. Cosine inverse of both sides. This is a great little review question right here. This is really good. So in your calculator, what mode should you be in? Degree mode. And so we want to make sure that you're in degree mode. Most of you will be in radian mode, so change your mode to degree. And then we're going to do cosine inverse of 5 over 13. And so we get 67.4 degrees. And that's going to equal the measure of that arc, YW. Okay. I think I'm going to stop there. I think that's probably just fine. All right, do you guys have any questions for me? Good? All right, cool. 23.